Okay, so in this video, I'll just be proving why the square root of 2 is irrational. So in Math 260, this will probably be a proof that'll almost definitely pop up. So I'll break it down for you. So to start off, easiest way, and as far as I know, the only way to do this is to prove it using contradiction. So to start off, the way I start my proofs is I'll tell the reader what the heck I'm going to do. So I'll start by saying we will use contradiction. So then assume that the square root of 2 is rational. And what does that mean? Well, typically that means that it takes the form of a over b. So root 2 equals a over b, where a and b are integers and b is non-zero. Also, we want to make sure we include that a and b are coprime. And what this means is that a and b don't share any common prime factors. So consider something like, I don't know, 21 and 8. 21 and 8 are both not prime, but they are coprime, because when you take 21, I'll show you over here, 21 breaks down into 3 and 7, and 8 just breaks down into a bunch of 2's, basically. So notice these are none of the same prime factors, so they are coprime. So then we have this then. If we have square root of 2 equals a over b, or a over b, then a equals b times the square root of 2. So then a squared equals b squared 2b squared, basically. So notice 2b squared is, b squared is an integer. So we have an integer times 2, so then we know a squared is an even number. And there's a proof that says if a squared is even, a is even. That you can do on your own. So we know that a squared is even, therefore a is even. So definition of even, I'll use that. So a equals 2 times k, where k is an integer. So now we can play around with that. I'm just going to move the rest of the proof over here just so I can kind of keep it on one page. So we have a equals b root 2. Just going to replace a with the definition of even, so we'll have 2k equals b root 2. So we have b equals 2k all over root 2, square both sides, so we'll have b squared equals 4k squared over 2. So b squared equals 2k squared, where k squared is an integer. And we know that because k is an integer, and an integer times an integer is also an integer. So we have, once again, that b squared is an even number, and therefore b is an even number. So I'll write that out. So b squared is even, therefore b is even. So now we've reached a contradiction. So we have that a is an even number and b is an even number. But at the very start, we said that a and b are coprime, and so they can't be reduced anymore, I suppose. So we have a contradiction. Since a and b are even, they are not coprime, which is a contradiction. Therefore, the square root of a root of, oh, come on, let me type in it again. Square root of 2 is irrational. And that's pretty much all there is to it.